Hello students, I am Dr. Tanmay Vishwash. I hope you all are fine. So today we are going to discuss one multiple choice question presented in front of you on this board. So as usual, I first request you please try by yourself because self-evaluation is essential for improvement, and that's why I request whatever answer you get, please write on the comment box. I want to know the efficiency of my students. Okay, don't hesitate, because if you right or wrong doesn't matter. If you understand your capability, that's best for you. Okay, so please pause the video and try by yourself. I believe you have paused the video and tried by yourself. So now it's my turn to give you right answer. Before going to details, I'll make a short request. If possible, please subscribe. Please support this channel using Patreon, and please do subscribe this channel if you like my content. Okay, so let's start. As usual, you can see this reagent reacted with mCPBA NaH2PO4. By the way, remember students, when you try to solve any question, it is for a chemistry related, this MCQ, it is highly important that you should understand what is the nature of the reagent. That's if you understand the nature of the reagent and reactivity of the molecule given, then it is very easier to find out what type of reaction possible. Okay, so that's why I first explained about the nature of the reagent. By the way, such kind of MCQ could be useful for the exams like any college or university related exam like BSMS, B.Sc, M.Sc, or competitive exam like CSIR-NET, IIT-JAM, etc. Even the JEE advanced or NEET candidate can also try this question. So just look at this molecule. Now you will be a little confused, sir. What do you mean by m-CPBA? m-CPBA is actually metachloroparbenzoic acid. What do you mean by parbenzoic acid? This is actually the metachloroparbenzoic acid, mCPBA, and this peroxy linkage, you can look at this. That's why this is called parbenzoic acid. And what is the fate of this reagent? This oxidizes someone and itself reduces and get this metachlorobenzoic acid. Means if it oxidizes someone, so it is reduced. Obviously yes, because in this case oxidation state is -1, whereas in this case oxidation state is -2. That's why it oxidizes someone. Now from this thing we understood it is an oxidizing agent. Point number 1. Second, if you look at this is actually a very weak acid. Very weak acid. Why I say very weak acid? Just look at the structure of the conjugate base, because this is the common tradition to explain the acidity of a molecule. So if you look at the conjugate base structure, you can observe that this conjugate base is actually, this O- is not resonance with this carbonyl. That's why this is pretty weaker. So this reagent is nothing but actually you may consider weak acid. Okay, so it is actually a weak acid. But is it actually a weak acid? So what is the conjugate base? The conjugate base of this is O-. See, right now this is in conjugation with this carbon, and this carbon is conjugation with this phenyl ring having withdrawing group. So that's why this is relatively stronger. So this is a relatively stronger acid. Okay, so from this reaction what we get? We get from a weak acid to relatively stronger acid. Relatively stronger acid. So that is the problem. Now question. Okay, I shall come why this thing is added later on. So from this much discussion you understood that this is actually a oxidation reaction. And what happens actually, it is the fate of this oxygen, this is transferred to someone else. Now question, in this case I have written two places benzylic. Benzylic means CH2PH. Just remember. Now let's draw the mechanism properly. So what happens? See, actually this is a epoxidation reagent. Please remember this term. This is a epoxidation reaction, mCPBA, or better to say electrophilic epoxidation. Okay, by the way, I have already discussed a dedicated lecture on this mCPBA epoxidation. Even there is another nucleophilic epoxidation using hydrogen peroxide alkali. So please visit those lectures. Fine. So this is. So first of all, and in this case, you should remember, student, about the transition state. Means how reaction. As I told that this oxygen is transferred. So what is the transition state expected? I'll draw. So this is the alkene, reacts with this. This is the O. This is the AR. AR means metachloro. This part is AR. Fine. Now, so what happened? It reacts with this alkene. Okay, because this is nucleophilic in nature. Then it attacks here. This goes back and this abstract. So what is that nature of the transition state? Please look at little carefully. Try to understand. This is, remember, in the transition state, the bond broken or produced is indicated by dotted arrow. Okay. So this is this and this is here. So this is the thing. This is the overall. I should represent this using a double dagger. This is called the TS. Fine. So what is the product after that? After that, the product is an epoxide. Means this one. Now question is, in our case, where the epoxidation will occur? See, from the molecule, from the drawing, you can understand that there are two types of double bond. Either this one or this one. Means, let's consider this is double bond 1 attached closer to BZ. This is double bond 2. Now question, which will be epoxidized? In this case, if we consider that double bond 1, this carbon after that OBZ, double bond 1 carbon after OBZ, almost similar in both cases, but there is one OH, that is the uniqueness. Okay, and that is the thing. So in this case, there is another interaction happened. If I represent that interaction, that should be that this is the oxygen. Okay, so better to draw with respect to transition state. So this is the O, this is AR, this is OH, this is OBZ, this is. Now what happens? Just I previously showed that this oxygen forms hydrogen bond with this hydrogen. Fine, that's fine. But if the molecule has allylic position OH, that actually acts as a directing group for hydrogen bonding. And how many rings are forming this hydrogen bonding? 1, 2, 3, 4, 5, 6, 7. We know the 7-member ring formation is not that much uncommon. Okay. So in this case, you should represent this way. So that is the reason why selectively this here the epoxidation occur. Okay. Now you can ask that, sir, why not this? See, in this case OBZ means OCH2PH. There is no hydrogen available for hydrogen bonding. So actually this is the directive, this group directs the epoxidation. Fine. So we understood that epoxidation will occur this side. So the product structure is, this is OH, this is epoxide, this is OBZ. Fine, we understood. Now question is, what should be the position of the epoxide? Because if you look at these centers, there is one hydrogen. So actually if you look at little closely, see, both are chiral center, this as well as this, 4 different substituents. Now question, chiral means since 3-member ring is cis, always remember, small ring always cis. So either two options, either it could be up or it could be down. Now as I told that this is actually directing where the epoxidation will occur, and this is above side. It forms hydrogen bond as I showed with the peroxide m-CPBA, metachloroperbenzoic acid. So consequently, the transfer of this oxygen to the double bond, to this double bond to form this epoxide is from above side. That's why the product will be in above side. Means this is above and this is above. Got it? So that's why, because since this is in above, that's why this is above. Hypothetically, if this was below, then what is place expected? It is expected to be below. Okay, so that's so what is the answer? Above, above, above. Option 1. Okay, so now So this we understand. Now question, as I told that I shall tell what is the role of this hydrogen phosphate. Just look at the product. So product is actually epoxide. Okay. I have discussed in a dedicated lecture about epoxide opening under acidic, basic and Lewis acidic condition or neutral condition. Please visit, you will learn more. So what happens if acid is present, this epoxide undergo protonation, means so it has a lone pair, so it will be protonated, fine. And if it gets protonated, there is a chance that epoxide may open up, because in the reaction medium lots of things are there. So and why this protonation will occur? Because of this presence of proton, means the acidity of the medium. Okay, now initially the reagent m-CPBA was not that much acidic, as I told, it's a weak acid, but produced one is relatively stronger acid. So in order to maintain the acidity, this is added as buffer. Okay, means actually it's a very weak base which consumes this acid such that epoxide remains stable during the reaction. So if you see anywhere this thing, or one multiple choice could be asked, that in this reaction what is the role of this Na2HPO4? It is as a salt, it is as an acid, it is as a base, or no, none of this you can consider. So in this way it acts as a base. Okay, so that is the role, that's why this is used. So answer of this today's discussion means solution is this. Now question is, if this question appears in your exam less than 30 seconds, how can you solve this problem? First of all, students, you need to understand the condition m-CPBA, sodium and a base. So it is actually a epoxidation reaction. Now question, which bond? See, both bonds are almost same electron rich, point number 1. Second, there is one hydroxyl which can form hydrogen bond with this mCPBA and do as a directing reaction. So reaction will happen to this double bond because this is closer to OH like allylic position. So in this case, this is above, so epoxidation will above. Now another thing, I have told only one equivalent, means I have didn't mention anything, means it's a one equivalent. So this is the product, blindly you can see. So other options, see what is the difference? This is above, this is down, not possible. These double bonds are obviously not possible because closer to this. Okay. Now, by the way, I have already discussed a dedicated lecture on Sharpless asymmetric epoxidation, where you can see this allylic alcohol, those kind of thing undergo epoxidation using facile method by like titanium 4+ and enantiomer selectively. Okay, so fine, that's a different issue. Please visit if you want to learn more. So this is the end of this discussion. I believe this video may be useful for you. If it is, please write your opinion in the comment box. Please do like the video and pass it over to your friends. And most importantly, please press the bell icon of the channel such that you will be notified whenever I shall upload a new video. So stay happy, stay blessed, enjoy the study. See you in my next video.